Hello everybody, I'd like to welcome you to my YouTube channel. My name is Steve, and this channel you're going to find a lot of videos regarding the Commodore 64. And what we're going to be doing in this session is we're going to be exploring some scrolling screens that I've been working on. And this is actually a lead way to try to get the machine language project underway, and also to help myself increase my understanding of how scrolling works and game design in general. So let's get started. Okay everybody, we are back, and this time on the desktop, and what I'm going to be doing is I'm going to be showing you the scrolling maps I've created, and essentially using the program that we created for the machine language project, how to go ahead and basically extend and create your other maps. So this is going to be a full screen scrolling that's horizontal and vertical scrolling. So obviously this is the game map here. We'll start with that, and this was extracted from Metal Warrior. So you can see my character on top of it, and I can move him around. It's animation. This is how the original project was when we were working on it, and I can move around in an actual game map. But this is not our game map, just keep that in mind. This is just a demo. Of course, there's not anything to block walls or anything like that, although it is included in the actual code. But to be able to scroll the maps, I wanted to show you, so we have no restrictions. I'm just going from side to side here to kind of demonstrate. Okay, I think I'm over far enough. You can see more ledges down here. So if I wanted to play it like the game, go down the ladder. But you get the idea, right? You're seeing a full screen scrolling map. And this is only one example. Now let's move on to the next example. Okay, so before we move ahead with this, I wanted to demonstrate a little bit more about the scrolling techniques. And what I'm going to be doing is showing you an article I wrote on my website, c64brain.com, that will demonstrate some of these techniques. So just go to c64brain.com. When you're at the home page, just scroll down a little bit, and you'll see it over here on the right hand side, Commodore 64 screen scrolling. Just click that link. And once it loads, you'll have a little bit of introduction here about Commodore 64 history and game design. And if you go down to understanding screens and scrolling, it talks a little bit more about the process, which explains that each screen is made up of all these pixels, and these pixels, which are the little dots on your screen, actually create what are called characters on your screen. And you can see an example here. It created, this is just the letter A, and these zeros and ones, these are in binary. I didn't explain that in here, but binary is what is used to create the dots. To calculate, it calculates all the rows here to make each of these the character individually. Okay, so I'm back here, and what I did is I loaded up Vice, which is the Commodore 64 emulator. And in this example here, I'm showing a map that I had created that actually I was going to originally use for the Spelunker before I even knew how to do scrolling. And just to kind of demonstrate, this is the screen itself, and it starts in the upper left-hand corner here, and all the way over to the right. This creates 40 rows of characters, which I explained on my website. And then as you go down the screen, it creates another 40 characters, but you have to add 40 each time you're going down the screen. And I'll explain this a little bit later in the video, but I wanted to show you. Over here in this corner, this would be the 40th character. So this is, I believe it's 1064 screen memory location. And then again, it goes 40 down here. So this line down here is necessary to understand, because before we start scrolling here, we have to know the data that's off screen here, and this is where the map memory would be contained, which is in memory, but it's off the screen, and then we have to kind of force it onto the screen. And to do that, we just copy it over here, and then it reproduces the effect over here. So it's kind of hard to explain, but think of it that way. You're basically copying one location to the other to get it back on the screen. And basically you're copying, and when you're scrolling the screen also, I didn't explain it in that, but I'll add a little bit more to my website. It actually scrolls in pixels. So remember when I talked about on the website that each character is made up of pixels? There's 8 by 8 characters made up. So each of these individual little sections here are made up of the pixels, and the pixels are scrolled from 0 to 7. So it basically allows them to scroll over here like that. You can't see it, it's very, very small, but that's what creates the fine scrolling. And once it hits 7 pixels, it begins anew. So as you see it move over like that, it scrolls 7 pixels and it starts again and again and again. And it also, what it's doing is it's copying these screens real quickly to what's called the back buffer, so that it can produce the screen faster. Now if you try to just display the screen and run it, it'll be a little bit quirky, and it just doesn't really look good. So it's better to copy it on the back buffer and pull it back to the front buffer. Which you see this number here in the upper corner that was demonstrated by my friend Siggy, who created this code sample and the scrolling. The 1 shows the screen it's on, so it's on screen 1, and then now you'll see it switch to screen 2, screen 1. So he's showing in effect the 2 different screens he's using to implement the effects. The Commodore 64 screen, as I explained, is made up of these pixels, and I'm going to demonstrate this in a simple basic program, how the scrolling kind of is basically how the screen characters are plotted on the screen and whatnot. So we're in basic. As I mentioned earlier, the Commodore 64 screen is made up of all these different characters which go across the screen. So if I hit these X's and repeat them across the screen here, these are 40 characters in a row until it gets to that side and it repeats again. Them very quickly to produce just the display you're seeing on the screen. And I was just using this as an example to show you. When I was talking earlier about the corner, this is what I'm referring to, is these characters off the screen here. When they're scrolling, they're copying everything that's in the map onto the screen over and over and over again. And this exchanges back and forth to create what's called the scrolling effect. And next, we're going to go ahead and introduce the color to the screen. Yellow. I believe it's 7. That's all I had to do is like that. And now you see it's got a stream of yellow A's going across the screen. Okay guys, so I'm back here and I demonstrated how to go ahead and, after a little bit of work, to draw a set of characters down the screen from the top corner to the bottom. One more, this is the basic program that does it. And it basically, again, reads the top lines from 0 to 39 to go across. And it pokes in the screen memory location, and it pokes in the color memory location, which starts at 55296. And this one is reading it from X to 0 to 22, which I'll change to 23, of course. And what it's doing next here is it's reading the screen memory location. So 1063 is 1024 plus 39. Then it adds X on each iteration here, so it moves it down the screen. And it multiplies it by 40 to get the next line down, since there's 40 lines across. And we run it, of course, we get the line going down the screen. Cool. So before we go on to the next example, though, I wanted to show you the code. I think that's only fair. Obviously, this right here, by the way, is the character pad. This is the map you just saw scrolling. And the map itself, which is right here, is 100 width by 15 height. And that's very important. I had to take that in consideration when I was learning this, because you actually have to set each individual map, and I'll show you where that starts at here. To show you, first of all, something important. This line right here draws the map, and this is a jump subroutine to this location. This is important to be able to draw the map on the screen as you see it here. So it draws the map before the player begins moving. And what it does is it captures parameters here for X and Y, and it puts them in these parameters, and these X gets passed into here to basically draw the map. And down here, this is the one that kind of stuck me for a while. I couldn't figure out what this add pointer was. It's a macro that is actually defining the map total width. Now, if you don't change this to the actual corresponding map, it's going to look kind of messed up when it first draws it on the screen. So this map that we're using here is actually 240 characters in width. Let me find it. I have it right. I think it's this one. Thought it was this one right here. It looks like it's this one. Oh, you know what? I never changed it for this. So actually, this is a 47 by 65 on this map. This is the map that we're using on the screen. But this is the location where you change it. So I guess if you make it beyond 100, it probably doesn't really matter. But you usually want to make it within the range of the map. If it's smaller than 100, I do believe. So that one is 47 by 65. And then what you do is you go down here to what's called the map line lookup low. These are the low bytes. This is the thing that stuck me for the longest time because I was changing everything else, but I didn't know what this was all doing down here. Now, I'll show you. First of all, this is all broken down. This is the original Spelunker game that I can demonstrate later. It's 64 width by 32 height. And I just commented out so it's not reading that in. Here's Metal Warrior 1 map. Here's Metal Warrior 2, Metal Warrior 3, and Metal Warrior 4. And then down here I have RoboCop and Monster and Mayhem. And it just kind of starts over with the high byte. Now, what this does, and maybe I'll need to put the map on the screen to show this to you. So what this is doing is it's reading the map position by 47 bytes each time. You can see this goes 100 to 47, 47, 47, and so on. And this is necessary because on this part because it's reading directly on the map. So let me kind of pull the map back up and show you what I'm talking about, since this is the one right here. So I'll move it all the way back over here, for example. And you saw this is where we started at the beginning, right? So this map goes from 0 here, and its tiles are 4x4 tiles, by the way. And it goes all the way over to 47. So if I scroll this over, that's 47 tiles. And it's important to take that in consideration because you calculate the 47 tiles as the length, and then you want to go down 47, which is why we're adding 47 to this, and 47, 47, and so on. So going back to the program here, I'll grab my calculator to show you what I'm talking about here. Pull it on here. So, for example, in this example, remember we started at 100. Anyways, it starts at up here at the top. It reads the very top line right here, where it reads the byte, and it reads the map low byte here. So it's reading that upper corner here all the way over to the very end. And that's what that other wherever I put it, it was up here on line 150. That's what this line right here is doing. This add pointer is reading the whole width right there, 47. And then it just goes down the screen over and over again to get each level. And you look here and pull my map, my calculator back up. If I take 100 and of course I add 47 to it, I get 147, right? If I add 47 to it, I get 194, which you can see is corresponding to here, 47 and so on, 241. And to make things easier, actually as a bonus here, I created this Excel program here that actually builds all this stuff for me automatically very quickly. All I have to do is go here and type in one value like this instantly, and it changes everything. So I know exactly what the calculations are going to be. And of course you can see that these are just being read in from the cells and everything. But it saves me a lot of time. Instantly, I get whatever I need to try to get my the answers. Because earlier I was using a calculator over and over and over again, and that was just a lot of work. I was like, no, I'm not going to keep doing this. I'm going to find a faster way to get things done, especially if I want to end up demonstrating or playing around with 20 to 30 different maps. That would take forever to do the calculations on. So as a result, I was able to speed up my time on getting my maps, my low and high bytes implemented. So now that you got an idea of that, I'll show you where it reads the files from. Okay, so down here, going to the bottom, this is just where it reads in the character maps. And you can see here, it's got increment bin, and it's reading the maps, mw4 map.bin. And essentially, that's just reading a folder. And I'm just going to pull them up here for a minute and show you. So I'm reading from my H drive here. C64 history. And then I go down here to what I call Splunker scrolling examples. And go into that's the actual project right there. And I go into maps here. And then these are where it's reading all these maps. So in this example, it's reading number 4 here. So it's reading all these right here. These are the attributes. This is the character set. This is the color, the map, and the tiles, which corresponds. If you remember when we were looking at the maps here earlier, I didn't show you all this, but if you look behind here, you'll see there's a character set here. So that's reading in the character set. There's a tile set, and then there's the map. So that's what I'm doing is I'm reading that into memory location hex 8000. And I'm going on down here, reading in the attributes here. You see the attributes and the tiles. And of course, the character set is right here. And these are the individual maps here that I can demonstrate later that I've already created, and I can instantly display them and run them on the screen so I can see them. And of course, this is our original one, our Splunker clone. This is RoboCop. This is Monster and Mayhem. This is all the Metal Warrior ones, all the way up to 4. There's also Turrican too, but I didn't want to use Turrican. But anyways, just to show you, let's go ahead and load up a brand new map, and we're going to replace this one now. And all we have to do is go back here and just start commenting out stuff, right? So we're already in the character sets here, so we just go and comment this out. And then we were doing 4 there, so if I wanted to example, see, I think RoboCop looks really bad, but we'll do RoboCop anyway. It didn't read it correctly after I had to change the conversions on the tile sets, but I'll show it to you anyway. And all I'm doing is I'm just uncommenting and commenting those other ones, so instantly it's going to point to that part of the program, right? Now I'll go over here and I'll load up the RoboCop so we can kind of see it. I don't think I have it here in an example, so I'm just going to pull this. This was the Monster and Mayhem, so I'm just going to pull the RoboCop one up. Which is right here, and this is the first one. But not all the tiles loaded correctly, so it's going to look kind of funny once we get it implemented here. Okay, so remember we did our increment bins first to read our files, and now we're going to have to go back and do this, which is comment out the ones we're not going to use now until I come up with a better way to do this, of course. And then we're going to look for our RoboCop, which is right there, of course, and just uncomment it. Oh. Okay. And then now we're going to go to our high bytes. And we're going to comment these ones out. And then we're going to uncomment our RoboCop. So now we're reading in our RoboCop. You can see that I wrote down here the map is 182 by 5. Just making sure I got it right. 182 by 5. And I think we're looking good. Okay, looks good there. Now we're going to go up to line 150. And we're going to change this to 182. That's our width reader. That's to read the map in. Because remember, this is just reading that draw map to get the map drawn on the screen correctly. So I go ahead and run that. When I was using this map, I had to convert it back from tile to character, and it kind of messed up some of the tiles. But anyways, let's go ahead and run it. And you have to set it back here to main so it knows where to read from. Okay, we're back, guys. I had a little bit of a stall here. I had to go ahead and fix my files. But let me expand this a little bit and show you. Okay, for some reason Robocop is giving me trouble, so I turned off the sprite temporarily just to show you. Like I said, see the screens? They didn't come in very clearly. They were kind of garbled and everything. Okay, we're back, and I loaded up a new map. This one is just another Metal Warrior. This is Metal Warrior number, what is it, level 3? It's all from the Metal Warrior 1 game, but this is level 3. Now, you're not really playing it because it's not like it's interacting with it. So I'm moving the character because the character moves all over the screen just to kind of demonstrate the map. And again, some parts of it did not load correctly because of that per tile character. But you can see, if you look at the background, the maps is loaded in correctly. And just some parts are kind of garbled, of course. This one is all pretty much one level anyway, so it just kind of goes up and then it goes up here at this point. To what I was talking about in the character pad section here. So we're reading, and this one is in increments of 200, so 100, 300, 500, 700 as we're going down the map. But anything down beyond here is not being read, so it's going to be read as, it's basically trying to read the next lines and it's messing up the map. But there is really no map there, because if we look again back at the example here, this is all just one level here. So it goes from there all the way over to there, pretty much. And then that's the beginning right there. So normally it sits like that and the character's down here as he's walking the screen, and then that's what the game level looks like. So yeah, you can see that the maps are working, and now on to the, I like to say the grand finale, or which is the actual game map that Siggy, when he created this code. Okay, so I had to load it up, but this is the original one that was given to me last year. Actually in 2007, yeah, it was last year, by Siggy when he was finalizing his scrolling routine. So this one allows you to pretty much go up and down the ladders. Just to demonstrate that for you. You can also fall off the ladder when he's not touching it, and he hits the ground, goes back to normal. He also drops down the tiles, and he can also go up the tiles. That number you see flashing up there, that's the screen showing the front screen and the back screen, where the back screen is being used to implement the fine scrolling, since monitors are not capable of scrolling well enough without creating a back buffer. I'm just demonstrating that, you know, he can fall every time there. No sound effects or anything. It's just simple map movement. But the whole idea now is I could create my own little map and, you know, implement it around the game now. So this one kind of goes up and down here. Detection is really, really good. Now if you fall off this one, I think you get stuck somewhere. I remember. Yeah, he gets stuck over here. So maybe the last thing I want to demonstrate is how to use CharPad and generate, we'll basically create like, take this Metal Warrior example here from level 1, and we'll just add something to the map and just kind of change some of the characters here. Okay, so here's the map, and then this is the tile set, and what we're going to do is we're going to grab something from here like, let me expand this out. Trying to make some more room here. So we'll change something in the main map here. I think that'll be good enough. You have to take the pencil, and then you have to click the tile, and then I think that's good enough. Hopefully he doesn't bump into that. And then I'm going to save this section. This is the map, so I'm only going to save the map. So what you do is go up here to File, Import, Export, Raw Binary File, and we're going down to Export Map. And these are originals here. Make sure I'm in the right folder. I want to get into the Scrolling Examples folder, into the Maps, and we're in Level 1, so we go into Level 1. And we don't want to lose our original one, so we're just going to do like map, I'll just call it map 2 or whatever. And we'll save that, and then we'll implement that into our actual program. Okay guys, I'm back, and now we're going to show you, I put these side by side. The little example of the little wall we created will appear in the map now as we walk over toward it. There it is. So you can see what we've done is we've created our own map, and we can actually scroll on top of it. So we can now create our own scrolling maps and do whatever we want. Well, that was a long session. Thanks for bearing with me on all of that. So the whole purpose of this was to demonstrate that I have actually learned how to use Siggy's program here to create my own maps in any kind of environment I want. I can basically load CharPad, take a map that's 4x4, and load it instantly into the program that was written there. And also, you know, just to kind of demonstrate going forward, we'll hopefully be getting back with the machine language project, and I'm going to be studying some other code examples and stuff like that. Now, one thing I never did show you is how did I learn all of this? Okay, so this book actually has all of the code samples, most of the code samples from that, from Siggy's project. I could go in and study the code samples myself. So if I got stuck on something and didn't know what was going on, I could be like, oh, I need to go back and look at that section and see why, for example, the map isn't loading correctly. Because believe it or not, in the very beginning, the maps were not loading correctly. They were kind of garbled, and it was just a nightmare until I really figured out what was going on. So I hope you guys enjoyed this video. We'll look forward to some more videos soon. And I'm real excited, guys, because now we've got a whole full scrolling map, and we can just start, you know, moving forward to create enemies and whatever now. Thanks for watching. And also, as always, please, I appreciate your subscription, so please subscribe to this channel to help me grow my audience. And thank you very much.